So there I was, and then a transistor came along and taught me, what the world for just basic switching. Keep in mind, most of the world uses MOSFETs nowadays for its switching techniques just because of the current demands and the speed of which MOSFETs can switch. Hence why they're used in amplifiers. Are used pretty much everywhere. Switch mode, power supplies, the whole bit and caboodle. So what we're going to do here is just simply put in the simplest version of the transistor, the 2N22222A. So we go up into our component, place transistor. You can type it in, if not, it's just right there. This is the one the 3904 and the 222A were the first ones we learned with. And getting to learn how to use the transistor, pretty straightforward base collector emitter once you've got your basic electronics class in your belt. But to me, for testing a circuit, making sure something works, except for oscillating circuits, for just simple DC schematics and stuff of that nature, I find that Multisim works just fine. But if you're expecting to see some, funky sine waves out of a transistor being used in funky ways, I haven't seen anything yet. Good luck. That's all I could tell you when it comes to Multisim. It knows the basics, as my teacher just told me. So you just basically put out your transistor, collector, base, and emitters. Nothing fancy. For most of them, we're going to be just using resistor packs. This standard resistors that you're going to get off the shelf. If you walked into Radio Shack, if they still existed, you'd be able to get one of these. And we're just using a schematic generally off the internet. Nothing fancy. I usually use a 1K for cutting inbound. And then I love it because you can just rotate the schematic. That's at least what I was taught back in the days. Just move it around. If you need to move the line, just do that. Nothing fancy, just simple stuff. So you got your simple divider, and then we're going to tie the base to that divider, because obviously you have to have a bias to turn on the transistor. That's what I love about Multisim right here. The speed at which you can design this is a lot easier than soldering it and failing or blowing up something. Most of the time it's just knowing where the emitter, collector, and base are on the transistor that you have. If not, use your catalog books and stuff of that nature. This is basically what we're going to call high bias. In other words, this thing's going to be driven pretty hard. Most of them don't drive it this hard. Most of them are usually, let's say, 3K. Each transistor works differently. So a 2N, 222A, and a 3904 are definitely going to play different. And most of the ones you're going to normally run into are going to be around 10K. Just checking our circuit. They're using a 13. Okay, so for safety's sake and illustration purposes, we'll put our capacitors in, just our standard electrolytics. 1 microfarad should just work just fine. Make sure you got them in polarity direction. Right direction, Control R to rotate the item into the direction you need. So if we need to, we're going to be introducing the signal here. And we're going to be taking the output from here, if I remember right, because most of them, that's generally what they do. Yeah. And this will go to your signal, or on your oscilloscope, and then your signal generator. Simple AC circuit. Simple. DC powered AC circuit. You're going to find this in most 9-volt, 12-volt operated devices, battery operated devices. You hit play, and you get to look at the output. Man, not bad for just off the keister. Wow. So we just took a roughly 2-volt peak-to-peak sine wave, and we amplified it out to roughly 5 volts peak-to-peak, almost 2 volts RMS on the output. So just off a basic circuit, and that's not even using the bumper cap. We call it boost cap or transimpedance capping, or they have different names for it, but I call it the bump cap because they're usually, if you look at a 12-volt amplifier output, you're going to find what we'll call a booster cap: 10, 22 microfarad, 10 microfarad, sometimes 100 microfarad for the booster cap, or bypass, or I call it bypass cap sometimes. Each of these 12 volt or automotive ICs have different namings for it, but hey, I just amplified a 1 kilohertz signal down near 1 volt up higher than the input. And if you ever wanted to see, like, being able to monitor, hey, let's see the input and the output, just be careful when you're using this so you get different colors. So we're going to say, hey, what does the input look like? You come up to here for the signal generator. You tie it, it's going to be red. And then we're going to change this one to blue, so that way we can see green, blue, anything that's easy to see on the eyes, on the scope, so you can see the differentiation. And then don't forget to tie your grounds. You hit play, open up your oscilloscope, make sure you're using the same channel division for each, so you can see what our input and our output look like in proportion, inverse in a sense, inverted. Just amazing. That's for the simple 222A, for signal generation, it works just fine. And I agree with the guy that when you're using semiconductors, or what we call, the old circuit designs, instead of using op amps and, what we call cheater devices to get signal boost with noise, I believe the transistors and the dual gate MOSFETs work just fine in the year 2022 for signal amplification, especially when you're playing with smaller radios, transistor radios, and stuff of that nature. And like anybody does that in the year 2022 anymore, right? With smartphones and stuff of that nature. But they're usually a basic, simple 2222A transistor that we normally would get in a generic pack from Radio Shack. Simple little AC circuit for amplification. And plus it also tells you that it's good for testing capacitors and their frequency response. You can just say, hey, where's the 1 stand versus where's the 10 stand? The function generator and these virtual circuits basically do a good job of basically saying, okay, hey, this is where, if you were to hook this device up in the real world, this is where it should look like. In theory, you have a 99.9% chance that it's going to look like this. But there's a simple, NPN, 1 kilohertz audio amplified sine wave, something you don't get to see. Like you have to go out and look at circuits that's biased, like an AB. It's basically biased on. And the reason we use that input resistor going down is just because, to me, for a lot of what I've seen when it comes to the signals being boosted or amplified or cleaned up, the down resistor helps do a lot of, keeps a lot of the total harmonic distortion down, very minimal, versus if it was just a class A, biased, like most of them use 100K or 1 megohm resistor to bias the base of the transistor for amplification. That transistor is on, but nothing's really yanking it down. Nothing's really nagging at it. So unless you got that nagging going on, I find that the THD will go up when you're not getting nagged. And if you nag that input and you're pulling it down, through a 4, 7, 10K, whatever resistor, doesn't matter. I find that you get a lot more clarity when it comes to the signal generation and amplification. And where would you use this type of stuff? Just in little audio circuits and stuff of that nature. General headphone amplification if need be, with low distortion. Recycling old electronics to use them in the year 2022, that because everything's so tiny, what use does it is now? Most people don't appreciate the stuff anymore. But there's a simple sine wave being pumped through a simple NPN transistor, and basic circuit Multisim 14. I was going to say multiplayer 14, but Multisim 14. This is basically one of the absolute basic circuits you're going to play with, get to understand good signal analysis, because you can change out that transistor and you're like, hey, what does this one look like? Well, what does this one look like? If I couple this one and this one together, what is it going to look like? And what if I change these resistor values before I go and do it in the real world? What's it going to look like? And I found that when I was designing circuits right out of Multisim, they looked good. They looked awesome. They were very close to the real world when it comes to seeing an AC sine wave. I used it for low frequency amplification, plugging into the ground and being able to amplify the signal into a sound card and be able to analyze it with the SDR Sharp. Yeah, I think, SDR Sharp, if I remember right. So pretty cool stuff. And I do some videos on that too, being able to look at signal analysis using some of what we call the SDR technology and being used for signal analysis. But this is your basic kit kit in the barrel, circuit that you're going to be using to troubleshoot a good, just get the understanding of a lot of, especially when it comes to amplification circuits, how a lot of the stuff works. Circuits are out there, but being able to test it and actually get to see it work, big difference. And like I said, who uses analog oscilloscopes in the year 2022? Yeah. So, like I said, good old signal function generator. Should have no problem, squeezing that frequency-wise. Look at that, 10 kilohertz passes through it with no qualm. Wide bandwidth amplification. Look at there. Oh yeah, absolutely. And then using the distortion analyzer, just a simple transistor. Used in what we'll call a most current, happy way to basically plug into a 12-volt battery and amplify something cleanly and efficiently and without making it sound like crap. Anywho, hopefully this video wasn't too long for the most type, but this is more of what we'll call an advanced circuit, especially when you're doing signal analysis, function generators, and staring at an oscilloscope looking at, a sine wave being passed through, just your simple, battery, resistor, capacitor, and transistor. Simple circuits. Like I said, there's way more complicated stuff. When I saw my first transistor, I was like, wow, SERs, diex, triacs, hex FETs. I got mad appreciation for the Sun amplifiers. So anywho, hopefully you enjoyed that. Multisim 14. Being able to do some general signal analysis along with a simple NPN transistor, something right off the shelf. You could pretty much open up any old ass electronics and pull one of these transistors out of it, if not a 2SC 905 or 950, or I think it's a 905. Got tons of them. But just your, hey, what does a transistor do and how does it work? And if you have any questions and stuff of that nature, like I said, just make your questions very discreet and simple, and I can answer pretty much anything you need to know about most of the circuits. If not, the internet definitely has the answer. If not, there's tons of, we'll call them couch arm patrols, the people that sit on the internet know more than you do and stuff of that nature, which there is. There's always more people that know more than all of us. But here we are making a simple video for Multisim 14, simple NPN transistor, audio amplifier, signal generator, and oscilloscope being used, because hopefully it'll help somebody in the real world use the tools in the right way, so that way we don't have to fix anything anymore, right? Other than that, peace out. Hopefully you enjoyed the video.